Okay, so we have considered, usually we have VS in series with RS, and RS and RI are in series, so it is considered, RS is going to be considered along with RI. We have incorporated RS plus RI as a single resistance RI. So first we will be finding what is the input resistance RIF. So our goal is to find what is RIF and R0F for all the 4 type of amplifiers. So first we have taken voltage series feedback, input side Thevenin's theorem, output side is also Thevenin's theorem because I have the term voltage. See, in this notation, voltage corresponds to output side and series corresponds to input side. That's how we draw the diagram for the amplifier. Okay, that is the reason why we are getting this diagram. So we are going to find what is RIF, and RIF is going to be Vs by Ii. See, if it is Ri is Vi by Ii. I have told this many times in the beginning itself, when you consider feedback, when you consider all parameters with feedback, you have to consider the source. So Ri means it is Vi by Ii. RIF means I have to consider Vs by Ii because of the external source. What is the input I'm getting, input resistance I'm getting with feedback. So I can apply KVL at the input side. If I apply KVL at the input side, I can write Vs equal to Ia into Ri plus Vf. Okay, so I think you should be familiar with the KVL and KCL, current entering node positive, leaving node negative. So you can write Vs equal to Vi plus Vf. You know Vi is Ii into Ri plus Vf. And you know in voltage series feedback, Vf is beta into V naught from this table. You should be very clear in this table. So beta equal to Vf by V naught. So Vf is equal to beta into V naught. So I substitute everything here. So Vs equal to Ia into Ri plus beta into V naught. Okay, so now I have to, only when I divide by II, I can find what is RIF. But on the both the terms, I don't have II. I have II only in the first term. Second term, I don't have II. For that, what you should do, I should find what is I naught. I should find what is V naught. So V naught is voltage across RL. So what is the voltage across RL? You know by Ohm's law, voltage across RL is I naught into RL. Okay, what is I naught? I naught is the current flowing through R naught. You can see a small loop here. So I naught is going to be total voltage AVVI divided by R naught plus RL. So V naught equal to I naught into RL. So I naught is AVVI divided by R naught plus RL. So see here, AVVI divided by R naught plus RL into RL by Ohm's law. V is equal to I into R. So I'm going to replace this AV into VI by R0 plus RL as AV dash. So it is given wrongly. It is given again as AV. It is actually AV dash. So where AV dash equal to V0 by VI. So it is AV into RL by R0 plus RL. So instead of having a very big term, I'm going to simplify that as AV dash. Okay, now substitute this value of V naught here. So Vs will be equal to Ii into Ri plus beta into Av dash into Ii into Ri. So now I have Ii common in both the terms. Take Ii outside. So Vs equal to Ii into Ri plus Ri beta into AB dash. So I can take Ri as common. So Ri, if I take it as common, 1 plus beta AB dash. So divide both sides by Ii. So RIF equal to Vs by Ii equal to Ri divided by 1 plus beta into